Welcome everyone. Today's session is about the importance of data in companies, as well as some of the biggest opportunities and challenges that come with using and storing data. We will also try to demystify some of the key technologies and trends around cloud, big data, and artificial intelligence. And to do this, I am very pleased to say I'm joined here today by Thomas Harrer, who is a distinguished engineer and the CTO for IBM Systems Hardware Sales in EMEA. Welcome, Thomas.
Thank you very much, Bernhard. I'm pleased and honored to be with you.
Yeah, no, it's my pleasure too. Maybe you can tell us a little bit more about yourself. You're joining us from Germany today, just outside Stuttgart. You obviously work for IBM. Maybe you can give us a little background of who you are and what you do for IBM.
Yes, so I'm sending here from Stuttgart, from the area beside Stuttgart, in a very sunny weather. The sun is shining. We have blue skies here. I was not in the IBM office for several weeks because of the pandemic situation we are right now in, but I'm engaging virtually with many people nowadays using virtual conferences, you can imagine.
Yeah.
So I'm with IBM since 25 years. After my computer science studies, I applied for a technical profession within IBM, and with lots of experience in the banking industry, in telco industries, a little bit in retail, where I helped to build infrastructures like mission critical systems, data warehouses, decision support systems, cloud-like systems, software-defined storage environments, etc. My career progressed very well, and I was able to take over a EMEA, or first of all, a European role as the sales CTO, where I'm the thought leader and advisor for our technical and sales teams. And since 2017, I'm now a distinguished engineer and the CTO for EMEA, which is Europe, Middle East, and Africa. And hopefully many people are here from EMEA. Welcome to that session. It's very pleasant for the time zone, but hopefully there are also people from the US where we have Thanksgiving today. So hello, everybody.
Yes, hello everyone, and happy Thanksgiving if you're joining us from the US today, obviously, or anywhere else where you celebrate this. Let me just, as always, let us know where you're joining from. I've said lots of people saying hello here. I've got Gerd from the Netherlands saying hello. I've got Lydia from Bulgaria. I've got Carrie saying hello, Bernard, hello, Thomas. So this is nice to see everyone on the stream today. I've got someone from Iran just saying hello, from Kansas City. Alexis, nice to see you. Yeah, so today's session is about data and the opportunities and challenges that come with it. So why is data so important to businesses today? You have the great opportunity to work with so many different customers around EMEA. Maybe you can give us a flavor of why data is so important and what some of your customers see as the main opportunities around the use of data.
Yeah, so data is already at the core of nearly every business nowadays, because all the interactions with customers, all the developments regarding products and services depend on data. But data is also knowledge. So there is so much to get explored out of more and more data that companies, organizations can generate nowadays. Just think about the situation we are right now in, pandemic, where the life science industries is looking for a vaccine or some treatments for the COVID-19 disease. And most of that research is done by data. So we have data from DNA or RNA sequencing, which gets more, it's so efficient nowadays that it could go into the clinical daily routine for every kind of patient to see what the genome is looking like, to understand if there are seldom rare diseases that are probably caused by a gene anomaly or something like that. So that's it's really everything that is new is depending on knowledge and data, and entire new kind of business models are entirely digital. They are only depending on the ability to share data. Think about a streaming business. It's flowing data. Data is flowing as videos or as music to people, and people are connected by the data. Of course, there's also this sharing economy business model based on data which connects people together. And Bernard, if you look into the companies in the world, the largest companies, so the top 10 of the highest value-added publicly traded companies, 7 of them nowadays are data companies. 10 years ago, there has been a very mixed situation. We had some oil companies, banks, telcos, retailers, investment funds. But now it's 7 are data companies, 5 from the US, 2 from China. And this shows, and the value of these companies is between 1.6 trillion and 700 billion of US dollars. So that's so data is really the oil of the economy nowadays.
Yeah, completely. And I always make the point when I work with organizations and speak to people that actually, you said that a lot of those top companies are now data companies, but the fact is that every business is now a data company, because data has become such an important asset for organizations, and it really helps them to reimagine the products they're selling, bringing into those products some of the intelligence, and helps them to reimagine their business processes. So do you have any favorite examples of how companies actually leverage data well in practice to illustrate the opportunities that exist around data in the business world?
That's a very good question. Thank you. Let me start with an example of still in the medicine area or the life science area. I had the honor and pleasure to give a talk together with Dr. Ramzi Timani. He's working for Citra Medicine and Research Organization in Doha, Qatar. Citra is a hospital for women and children, so with 400 beds, a very modern one, and is also participating in the Qatar Genomic Program. And Citra has implemented a very flexible data lake to get the genomic data managed very well and to get much better leveraged compared to a more traditional solution, because Citra is really doing what I talked at the beginning. They are using the genomic information, so DNA sequenced information, to diagnose what's going on in their healthcare processes. And you can imagine that changes a lot. If you have the knowledge, if you have the data, you know what can be done. It leads to a more precise medicine. Now, in the past, we had medicine which had big groups. We had a group of all people for one single treatment. But it's about to shrink these groups to have more individual treatments. So probably going into a group of one. So you know exactly which kind of treatment is the best for this individual, and then you can apply the best surgery or the best treatment for her or for him. So Citra is really a leader, and it was good to have that conversation with Ramzi Timani.
Absolutely. So and there's so many opportunities for every single business. I think just being able to personalize things like medicine is fascinating. Absolutely. And this is all enabled by data. I'm just having a quick look through the stream. Lots of people are shouting out and saying hello. I've got Cheryl here from Johannesburg in South Africa. I have Brahim from Algeria. We have Dolores from Dallas, Texas. We've got Monica from Brazil saying hello, George from Madrid. Someone else from Brazil, which is nice. We've got Salam from Saudi Arabia, Raphael from Nairobi in Kenya. We have Mahdi from Iran. So it's great to see. Thank you very much. And these sessions are always meant to be for you who are listening, whether you're listening live today or you're listening on my YouTube channel or on my podcast. The beauty of the live stream is that you can take part in this discussion. So if you have any questions for Thomas around data, especially around data storage, cloud, and so on, let us know, put them into the chat, and we will try to bring them up. Also, if you have any comments, if you disagree or agree with anything, just let us know. This makes these sessions much more interactive. So, Thomas, we talked about some of the opportunities when it comes to data, and I don't think there's anyone who can deny that data is now one of the most important, if not the most important business asset. But what are some of the challenges when it comes to data? What are some of the things that organizations need to be aware of, they need to think about, they need to be careful of when they, because I guess they need to find the data, they need to store this somewhere. There are lots of different issues around this. So what would you say are some of the key challenges that you and your customers are seeing?
Yeah, because of the efficiency gains in the way to generate data and to store data efficiently, we also saw a tremendous growth in data. It's an exponential growth that can be seen for the last 50 years. So every year, the availability of data is growing by 40%. And you can imagine it doubles every 2.5 years, or even quicker than that, bringing us into very big dimensions of data that needs to be handled, managed. So the size of the data is a challenge by itself. But also to find out what is important in the data, what is less important, what is active, what is a passive data set, to understand the qualities within the data, the importance. That are some management activities that have some burden for many organizations. Performance is also a problem. If you have more data, and probably I can give you a few numbers, how much data we expect to generate. 165 zettabyte by 2025. That's the amount of data that the world has generated, will have generated. Probably it will be even a little bit more. These predictions are around for a while. So the question I always try to answer is, how much data is that? And if you put that onto CD-ROMs, so these silver things that used to deliver music in the past, nobody remembers that unless you are old enough.
I am old enough.
Yes. So if you put 165 zettabyte on CD-ROM, it will be a staple which is 290 million kilometers, which is from the Earth to Sun and back again. So it's huge. And I always also try to compare it with the DNA. If you store it in DNA, how much is it? It's only 690 gram of DNA. So it's you see, biology is very efficient. But in technology, we need to manage and become efficient. We need to provide performance, for example. Another example from a client which is DESI, the Deutsches Elektronensynchrotron. It's a synchrotron in Hamburg, which is not only used for physics modulations, it's also used as a synchrotron beam for crystallographic X-ray analytics. For example, to understand the protein structure from the molecule interference. And to get to such a picture, it creates gigabytes per second of data that needs to be stored and processed and also archived, because the research results need to be available for a while. If there is some debate 5 years later, the researchers need to prove how they got to these results. And DAISY also, they decided to use a software-defined storage and appliance from IBM called the Elastic Storage Server Spectrum Scale as a global file system, which is so scalable that it can cope with these amounts of data. And it can also manage the data by automatically moving data around. The hottest data is on the fastest flash storage, and the cold data, but still relevant in the next 10 years, will be migrated to tape automatically with Spectrum Scale.
Very good. Yeah, we'll go into this a bit more detail because I want to make sure that we are demystifying some of those terms. Okay, what is cloud? What's hybrid cloud? What's multi-cloud, private, public? What's flash? What's the benefit of tape? We'll hopefully go into this in a bit more detail. And just looking through some of the comments, Salam is saying here, can you, no, what is okay, the impact of technology. There was another question around can you recommend a platform for medical data? Yeah, here we go. Can you suggest a good data platform that can handle medical data? And then another good question here. When it comes to big data, what are the options for small businesses in particular? So we will come back to those questions, I think. Thank you so much for because hopefully we'll cover those. But before we move on from challenges, I think one challenge is obviously to have the right efficient storage, the right storage for the right type of information that you need. And as you said, some information you need to have access to immediately. You want to have this somewhere in a flash storage. But then there are other challenges around regulation, for example, around security. Do you want to go into that as well?
Of course, I would be happy to do that. Should we just start with some kind of definitions or what I think about cloud and what it is?
Absolutely, yes. Yeah. Traditionally companies have stored data in their own data centers. Now we have the cloud. Maybe you can just define what your view of cloud is and what the different options are.
Yeah, so the first thing that comes into my mind is a statement that a cloud is someone else's data center. But that's not the entire truth of that. So cloud is, let's say, more a software enablement for how to distribute workloads in a better way. Nowadays, we clearly have the public cloud, so different larger and also smaller providers for public cloud services who provide infrastructure as a service, platform as a service, software as a service, and so on. Goes up to industry platforms. So, and there is the private cloud, of course. Traditionally, many established organizations, they use their core IT environment to support their business, and they did that on their own premises. Of course, there have been some outsourcing, some service provider relationships where the company provided the IT services for another company. That was already in place. But cloud means that some access to compute and storage is automated, is very efficient, because you don't need to build something by yourself before you can start. Another company already has built that for you. So they build a stack. It's still, at the end, it's infrastructure. It's using computers, it's using storage, it's using networking. But there has been engineering effort to put that together, to implement it, to have intelligent functionality on top of it, and you can just start using that. Nevertheless, you are also giving away your data into the hands of others, which is not new, but this is the reason why companies are also considering a private cloud, which means they just implement an infrastructure and a platform like a containerized orchestration platform with some software elements that can be easily accessed. And then the developers and also business functions can access already existing functions and can create intelligence out of that. So public cloud and private cloud together are making some kind of a hybrid cloud, but this also needs to be connected to the critical core systems which have been established years ago and which are optimized for this transactional integrity and the high volumes of transactions, where 90% of the world depends on. If you're doing a credit card transactions, you want to be sure that this transaction is safe, consistent, does not go away, and this still continues to be there, the mission critical part of many organizations. Some of them may be re-implemented, modernized to become cloud native, but most of them stay more in a high available transactional format in a classical data center, or could be also in a provider data center. And the hybrid cloud nowadays is to combine these elements and to integrate them on an application and on a data layer to build a real platform that businesses can act with agility. They can develop new functionality. They can connect to their customers. They can get insights out of the data. Can use artificial intelligence on a platform that is easy to use and quickly to deploy.
Very good. So
going into public cloud, the reason is compliance and also cost. You already touched that.
Yeah, so what I take from this is that it just gives companies an immense level of flexibility when it comes to their data and a lot more choice. I think in the past, people thought about cloud as this public cloud, a bit like what you use to store your photos on your iPhone or your Android phone. This is all stored in the cloud. Nowadays, companies have huge flexibility. So the technology has moved on. If you are a bank that needs to have control of their data, if you're a medical organization that has to have control of their data, you can have this on premise. So you can have the same technology, but you have the server, the technology on your premise. And to this multi-cloud, hybrid cloud environment is fascinating and enables companies to really figure out and optimize where to store what data. There's a question here from Candy saying, do you think storing data in the cloud is safe? And what's your response to that, Thomas?
So it's good to be skeptical. So there are legal rules how governments can access data that is stored in some places, and the cloud sometimes needs to be restricted in a way that a foreign country is not able to get the data that you have stored in data centers where you never had thought about that the data could go away. So it's always good to be skeptical, but we need to make sure that the contracts are in place that certain things cannot happen. But from an overall point of view, there's still some concepts or some legal rules nowadays that make it difficult to control all your data in the cloud. But it's also true for your local data. So if there is some governmental affair that requires you to disclose the data to a governmental organization, then you have to do that as well, for sure. So a cloud gives you flexibility, gives you, say, the ability to innovate without upfront investments too much. But if you are thinking through it, a private cloud gives you control, security, and the same level of flexibility and agility. So it's about to mix those two patterns. When it comes to the contact to customers, mobile applications, the direct channel to customers, or even the direct channel into machineries, the Internet of Things, the devices that generate data. This data is shared across the globe, and it will be concentrated best in a public cloud. It even would be useful to calculate certain functions outside the cloud data center in the so-called edge. The edge computing is an addition to the hybrid cloud concept, where the data is processed. The data is processed where it is generated. It could be manufacturing sites, it could be hospitals, it could be in the traffic situation, the cars that are going around. So these are my thoughts on that.
Perfect. Very good. So we have massive flexibility. When you work with customers, what choices do you take them through? What are some of the key considerations that they need to make? So how do you, if I'm now thinking, okay, I have huge volumes of data. Some data is streamed, some data is core, some data I process on the go, some data I just need to keep for a long time. So how do you come up with the right strategy here? And what are some of the thought processes and some of the things that you would help companies to go through to come up with the right cloud solution for them, the right storage infrastructure for them? And maybe when you talk about this, we can try to answer the questions around medical data and also what this means for small companies.
Yeah, and that's an excellent question. The most important thing is to understand the requirements and the goals and to translate that into the right technology solutions. So there are good requirements for, let's say, a worldwide distribution of data to access data, and this will probably go into a public cloud. There are also requirements for highest performance, and typically the data needs to be stored where it is used. So if we think about gigabytes and terabytes per second of data access, then it does not make sense to transfer that over the internet into another data center. We need to process it where it is. That's the other thing. And then there are requirements regarding security. And if you have high security environments or legal requirements like in medicine, data encryption makes a strong difference. Mm-hmm. So it's also easing the regulation. For example, in the European Union, the GDPR regulation means if you lose some data which is not encrypted, you are fined for that. But if the data is encrypted, that is a mitigation for that. So you can be sure that nobody has access to the content of the data. And certain technologies allow for very smart encryption of the data. And when it comes to availability for extremely mission-critical systems, systems like two-sided HA environments, for example, based on the hyper-swap functionality of an IBM Flash systems, they are well positioned to fulfill these requirements.
So can you give me a practical example of where you would want to use something like that?
So a customer of us decided to use IBM Flash systems, even the most affordable ones, the Flash System 5000 family, for HA configurations. For an HA means high available configurations, which means having two sides, the data is mirrored synchronously, and if one side is going down, the latest transaction is still present there. Often this is used for SAP HANA environments, which are critical for most companies. So SAP customers who move towards HANA, towards S4 HANA, they want to have a very robust and high available infrastructure. A very good example is Shibuya. Shibuya is an IT provider in Sweden. It's part of Pulson Group. Shibuya is named from this intersection in Tokyo, which is the highest crowded traffic intersection in the city. And nevertheless, in Tokyo, it works very well. People do not hurt themselves. And Shibuya is using IBM Flash systems together with SAP HANA on Power, on the IBM Power platform, to create a very stable and performant infrastructure.
Very good. So for your most critical, mission critical systems, you want something that is mirrored. So if one might break down, you can still be up and running. So this is something immediate access. Then what sort of data would you put into some other systems, and what data would you put onto tape, for example? Because tape is not going anywhere. People think about exciting flash storage and cloud systems, but a lot of data is still stored somewhere on tape. So what are some of the considerations here, and what are some examples of when you would use what?
So that's an excellent question, Bernard. But may I have another thing in the middle of the critical data and the tape? So if we consider modern cloud native applications, these applications do not have full consistency requirements on the data because they can have several copies of the data. They distribute it into several cloud data centers. And typically the model of that, it could be even having no persistent data, so you're throwing it away after it's processed, or with some kind of asynchronous persistence where the consistency is done over the time. And it's part of the cloud native development with containerized applications or with many microservices. That is, let's say, the development direction for most organizations to build new functionality in that cloud native model. And for that, the storage requirements are different. So you don't have only 2 sites, you could have many sites, and you need the right software environment to support these cloud native environments. And coming back to the IBM Flash systems, they are supporting, for example, Kubernetes and OpenShift from Red Hat with the container storage interface, where you can have very flexible and nevertheless performant and good storage for these container native and cloud native environments.
Okay, so you've used the word container a few times. For anyone listening that doesn't understand that, can you explain that for us?
Oh, yeah, you're welcome. So a container is a software element which is very lightweight. It's something similar to a virtual machine. Virtual machine is virtualization of a server, of a computer, giving you a local environment that is separated from other environments, but it contains an operating system. It's very high weighted. A container is a software environment which does not have a own copy of an operating system. It just has the application code in. It starts in milliseconds, and a swarm of these containers can be used to build cloud native application consisting of microservices. A microservice typically is implemented in a container. It's used for exactly one service. It's very fast. It's starting fast. It's shutting down fast. And it can be scaled very fast. So if you need not only 10, you need thousands of them, the software is taking care of that. So it scales very quickly.
Very good. Okay. And then tape, when would we use that, and is it how relevant still is tape?
So tape is very relevant. You can use tape for any kind of data, but typically it's more used to archive data or to backup data. To backup means having a copy of the data for security or for safety reasons. So why is tape so important? Because tape is the most efficient storage medium overall. And compared to the other technologies like flash storage, or even the hard drives, the traditional ones, they are, let's say, not improving their efficiency as we would like to have it. So the efficiency gains are slowing down a little bit, but tape is still having exponential efficiency gains. So we already have tape development examples where we could already show the tape abilities in the next 10 years. And this is a growth rate in efficiency of more than 50% every year. And this shows you that tape will outperform all the other storage elements over time when it comes to cost per gigabyte or per terabyte or even per petabyte. And why is tape, let's say, not used for everything? Because it takes a while until the data is being accessible by a tape. But think on a large media library, so a streaming service that offers videos. So if the service is having the first 2 minutes of the video coming from a fast storage, then people can start streaming the video, they see everything. And after a while, the data could come from the tape, because after 60 seconds, the tape is in the tape drive and is streamed. And then the overall experience is as the data would be online all the time, but the cost situation is you only have to pay high cost for the storage for the first 2 minutes, and the last 1.5 hours, they are really cheap and affordable and the best performance ratio. So why not doing that? And the same is true for any kind of storage. If the storage is not used too often, but you still want to have it, like in the research area, you want to have it for 10 years or for 20 years, but you don't want to have it on your fastest storage, then a software that migrates it to a tape transparently and brings it back also transparently when it's accessed is helping a lot. And tape is also good because nowadays many hackers are encrypting the active data. Ransomware is a real big danger, and the tape provides a real air gap. So you can make sure that no hacker is able to destroy the content of a tape. And even if everything else was destroyed or encrypted, if you have a tape and managed properly, companies can restore the data, hopefully back, and get back into operations without paying the bitcoins to these criminals. That's another very important aspect of tape.
Fascinating. They're really great examples. Thank you. I just had a question come in here from Dr. Alab Singh saying, is blockchain inbuilt into the cloud ecosystem? Do you have a response to this? Because for me, one of the advantages of cloud is that you have access to all the services and the additional benefits of things like AI and blockchain and other add-ons that will make your data really useful. So what's your response to Dr. Singh?
Yeah, and Dr. Singh, that is a good question. Blockchain is, let's say, a intelligent functionality which can be considered as software in the first thought, but the software is deployed in many clouds. For example, in the IBM cloud, you can get the Hyperledger Fabric, which is a very well-suited blockchain solution for business blockchains, because it's a permissioned blockchain. It's not like the Bitcoin network where you have this very intensive proof of work, which costs so much energy. So permission blockchains means in a business context, you can trust that your data that is stored on the blockchain is not changeable. It's muted. And so the truth, the authenticity of all the information can be proved without using too much energy to have that proof of work. And other offerings are available in the clouds. You can also download the Hyperledger Fabric software on your own machine and build a blockchain network with partners, with peers who have the same code running on their machines. So it can be done on-premise in private clouds or from the public clouds. But in a public cloud, the issue could be you cannot trust the security mechanisms. So if there are some critical elements like the private key of the whole blockchain, if they are compromised, then you are really damaging the whole concept and the whole business idea behind that blockchain. So it's important to have the most securable technology that is available in the market to truly have that blockchain hosted in a public cloud.
Very good. Let me just see. There's one question here from Pedro, who calls himself the Data Ninja, and he is saying for his customers, it's about a quick how fast you can spin up, the flexibility to manage, and how fast and how trustworthy and secure your data is, and obviously how cheap it is. And he's asking how does IBM distinguishes itself trying to balance some of these different wishes that their customers might have, balancing efficiency and security and so on.
Yeah, that's a very good question as well. So efficiency, security, and speed are elements that need to come together. And I have another customer example, which is TM Solutions. It's a hotel provider in Sweden as well. They choose, or they try to deploy new storage. And they looked into 2 tiers of storage, so flash and more affordable tiers. But they saw that with a IBM Flash System 5000, they could get an all-flash solution with even lower cost than a mixed solution. So that means that Flash could be already in a way that companies can leverage it much better. So they get 10 to 20 times better performance compared to a solution they had. And if they combine that with tape, so we call it a FLAPE, flash and tape, they get the best of both worlds. So, and regarding the management of that, regarding encryption, you need a software stack that is flexible enough to provide you with that. We also want to have compression in that or data reduction in that. And the software that we are now using, which is called Spectrum Virtualize, which is part of the Flash systems, is now our single software element for all of our Flash systems. So it's a very simple model. The smallest to the highest high-end systems have the same software code that provide management functionality, high availability functionality. They could help you with encryption, with compression. And so that's probably a very IBM-centric answer to that question, but it shows how a special development like the Flash systems, so very unique optimization of Flash technology in a affordable appliance in a box that can be put beneath a Spectrum scale file system that could be also used as a block device directly. That's the building block for many demanding storage applications. And you can also access that, for example, in the IBM Cloud as part of, for example, the Power Virtual Server offering that we have, where we also use the Flash systems.
Very good. And yeah, let's go back to small businesses, because this is definitely something that has come up earlier. And I just see Lourdes is asking here again, is cloud also fine for small businesses? So quite a bit of interest around what it means for small or medium-sized companies, and what would your response be, and what do you see as good solutions for smaller companies?
So smaller companies are also able to use the best innovation out of data and out of IT infrastructure. And cloud is a vehicle to support that. It does not need to be always the public cloud. It will be a public cloud in some cases, but if there is some very special needs, or if you look into the cost, then a private cloud could be the better solution. So there have been some companies who even started at the public cloud. So they were born on the cloud, they were a full cloud native model. And after a while, they saw it's difficult to control that and to make sure that everything is as they expect to have it from a governmental regulation point of view and other aspects, and also from cost aspects. And they decided to use an own data center. They put their own infrastructure in the data center, saving tremendous cost, having much better control. And this was not a big company. It was quite a startup, which nowadays is a well-known big company. But you can see even for companies with only a few people engaging there, a good model between a public cloud and a private cloud could make a lot of sense. And at the end, it's always technology. A cloud is nothing else than a stack to use computation, to use data in a smart way.
Yeah, very good. I'm just seeing Pedro saying, thank you very much for your insightful response. So he was happy that his question was answered. Absolutely, and I think cloud is in particularly relevant for small businesses because it gives you this flexibility and the scalability. So you, in an ideal world, you only pay for what you use. So if your business stays small, you pay small. When you then scale, you can scale fast. And I guess during this whole pandemic, what we've learned is that the more you rely on cloud, the more flexibility it gives you, but also the easier it is to have a resilient business in place that can cope with the ups and downs that will present itself in the future. Then looking into the future, what do you see ahead in terms of technology? What are some of the innovations that you get excited about, that you think, okay, they are things that if I was running a business, I need to start to consider some of these technologies now. They will come along, they will transform our businesses. What would be some of your key tech trends that you see on the horizon, and also maybe some of the implications this might have on data, on storing data?
Yeah, clearly the hybrid cloud platform is the next big thing from my point of view. But if we look into the basics, so we experienced a exponential efficiency gain over the last 60 years. You probably have heard about the Moore's law. Gordon Moore, who was at Intel in the 60s, published a paper about efficiency gains. So how many transistors you can have in a square area. And he predicted that it will double every 18 months. And this was just in the middle of the 60s. And when you remember back at the beginning of the 70s, a chip or processor had a couple of thousand transistors. I started at 85 with an 8-bit processor with my first computer. No, it was even 82. And these machines had only a few thousand transistors. Nowadays, the biggest commercial processors or the GPUs in the market have more than 20 billion transistors. And it continues to grow in a pace like 40% growth per year, but it will come to an end for sure, because the development in the past was based on shrinking the transistors, making them smaller and smaller. But at some point in time, they cannot be shrunk anymore because they are already hitting the atomic size. Of course, we are now at 7 nanometers of structure, even 5 nanometers is out there. And we have a roadmap for the next couple of years to scale that further with some good technology contributions from laser technology from Europe as well to make that possible. But then it will be difficult to have the same principle continuing as we saw in the last 60 years. But there is, for very demanding areas, we have two additions to that scaling of transistors or storage devices or even networking. So all these three elements are important. We have ideas about AI computers. So our brain is more efficient than any chip nowadays, but this could change. So we can build processors that are learning from the way how our brain is doing the neural processing. And IBM Research, for example, has a roadmap for AI hardware, artificial intelligence hardware, which will have a 1,000 times better efficiency in the next 10 years compared to today. And they are using analogous computing. So it's no longer only digital, no longer only transistors, it's analogous, and it's an in-place processing. So instead of moving data from storage into a main memory, into a processor, and calculating something and moving it back, the values are already where they are processed. So that's exciting for me. I see a lot of applications possible if that efficiency is realized in real products. We will see artificial intelligence everywhere, not only in the cars where it started with the autonomous driving, it will be even in smaller devices. So the world will become more intelligent.
Very good. Yeah, sorry.
I just want to mention there's another big area where researchers have dreamt about already 20, 30 years ago, which is the area of quantum computers. So the first quantum algorithms have been described in the 90s, and the concept was out there, but there was no way to build a real quantum computer. But now we have the first real quantum computers. And for example, the largest quantum systems that IBM has built, they have 65 qubits right now. And we are expecting that the volume out of that quantum computers, the real abilities, how they can process the world, will double every year. And we even have better efficiency gains than predicted. So the quantum computers that were released this year even outperformed that prediction. And not everything will be solvable by a quantum computer, but very intense problems like the simulation of molecules for finding treatments for COVID, for example. This can be done very elegantly by a quantum computer, or finding better batteries for the energy problems that we have.
Very good. So anyone listening that finds quantum computing mind-blowing, maybe you can explain this in a bit more detail, what it actually is, because quantum computing basic is when we go to a new computing model that is at the subatomic level, and it enables us to perform computing operations that traditional machines would be impossible to do. And they could basically give us computing power that is 1 billion times faster than what we have today. But do you have a way of explaining quantum computing from your perspective?
That is not easy, but let me try. So a traditional computer is using bits, which can have two different states, 0 or 1. And if you add additional bits in a linear way, you can build larger numbers. So having, for example, 16 bits, the largest number is 65,536, as you can apply for that 16 bits. A quantum computer is using quantum effects to do it differently. A quantum bit, a qubit, so-called, has the ability to span a Harder square, which means it can be 0 and 1 at the same time in different positions. So superposition is it called. So we have the ability to span a room of different values at the same time. And then qubits, quantum bits, could be entangled, which means they are connected together. So they react in accordance to the others. And with that, if you have 2 qubits, you have, let's say, double the number of different abilities. If you have 3 qubits, it's again doubling. So from 1 to 2, it's going 2 powers 2. And then if you go to 16, it's going to 2 powers 16. Different states that can be modeled. And with every qubit, the number of states is doubling. So it's scaling exponentially. So every qubit that you add is doubling the power of the quantum computer, unless it is stable enough. So typically it's difficult to scale it because the error or the time that it contains, it stays stable, is also shrinking. But we made so much progress in that. So we have quantum computers with 65 qubits, which is already huge, which are quite stable for today's processing. But the roadmap that IBM has done is showing that we will see quantum computers of 1,000 qubits in the next 2 years or 3 years. And we are going into the 1 million qubits until the end of the decade.
Amazing. I could just carry on this conversation now for the next hour, because there's so many other questions I would like to explore and discuss and get your points on, but it has been fascinating. So just talking about the importance of data, the opportunities and challenges this brings for every organization, and the implications for data storage, the different options we have, and to look into the future. So thank you very much, Thomas. Anyone who wants to re-listen to this conversation, you can do this on my YouTube channel, or you can sign up for my podcast, where you can listen to all the amazing and fascinating discussions I'm having with some of the most intelligent, some of the tech leaders in across the world. So there's always a chance to find more if you want more on my YouTube channel and my podcast. And until then, thank you very much, Thomas, for your time today. We need to find some more time, because there are so many other questions. I wanted to talk about storing data in DNA, for example, the super efficient way that our body uses to store data. So there's a lot more that we can explore in the future, and hopefully we'll find some time to do this soon. Until then, everyone, stay safe and enjoy the rest of your day. Enjoy the Thanksgiving weekend if you are in the US. And I will speak to you soon. Thank you.
Thank you very much, Bernard. Thanks to everybody who was here.